Hello everyone. In this video, let's practice some multiple choice questions from the chapter Probability. Questions mostly asked from this chapter are from the following scenarios: throwing dice, tossing of coins, picking a card, or picking a ball from a bag of colored balls. Few questions of miscellaneous type are also asked. So let's cover all these scenarios in this video one by one. First question. If P of E denotes the probability of an event E, then which of the following options are correct? We know that probability minimum value is 0 and the maximum value is 1. For an impossible event, the probability is 0, and for a sure or a certain event, the probability is 1. So option C is the correct answer because that's the only option where both 0 and 1 are included. 0 less than or equal to P of E less than or equal to 1. Next. A fair die is thrown once. The probability of even composite number is. So when a fair die is thrown, the possible outcomes are you can get 1, 2, 3, 4, 5 or 6. These are the possible outcomes. So what is the number of the possible outcomes? It is 6. Now we need to find the probability of even composite number. So which will be our favorable outcome? 4 is a favorable outcome. It's an even composite number. 6 is also an even composite number. So our favorable outcomes are only 4 and 6. So number of favorable outcome will be 2. Probability is found as the ratio between number of favorable outcomes to number of all the possible outcomes. So it is 2 by 6, which is 1 by 3. Option B is the correct answer. Next. Two fair dice are rolled simultaneously. Probability that 5 will come up at least once. When two fair dice are rolled, the outcome is recorded as two numbers separated by a comma. The first number shows the result of the first die, and the second number shows the outcome of the second die. So here in this picture you have a 6 on the first die and 5 on the second die. Like this you can have many combinations. It can be a 1 and a 1 or a 1 and a 2, 3 and a 5 or 2 and a 6. So all such possible outcomes are generally tabulated so that we don't miss out anything. You can see here there are 6 rows and 6 columns. So the number of possible outcomes here is 36. We need to find the probability that 5 will come up at least once. Either of the two numbers should be a 5. So here this is a favorable outcome. This entire column we have a 5 and this entire row we have at least a 5. It can be two 5s like this as well. So the number of favorable outcomes will be here you have 6 and here you have another 1, 2, 3, 4, 5. So total number of favorable outcomes will be 11. So your probability is given as number of favorable outcomes divided by number of possible outcomes. So it is 11 by 36. Answer is B. Two fair dice are rolled simultaneously. What is the probability that the sum of the two numbers appearing on top of the dice is equal to 8? So here again, two dice are rolled, so your number of all possible outcomes is 36 as shown in this table. Now, cases favorable to us are when the numbers appearing on top of the dice add up to 8. So where do we find such outcomes here? 6 plus 2 is 8, 3 plus 5 is 8, 4 plus 4, 5 plus 3, 6 plus 2. So you have 1, 2, 3, 4, 5. 5 favorable outcomes. So number of favorable outcomes is 5. Probability will be 5 divided by 36. So answer is option A. Next sum. Two fair coins are tossed. What is the probability of getting at the most one head? When a coin is tossed, you either get a head or a tail. In this case, two fair coins are tossed. So again, the result, we can write it within brackets. First one shows the result of the first coin, and the second alphabet shows the result of the second coin. So you have in this image a head and a tail. What are the other possible outcomes? You can have head and a head. You can also have a tail and a tail. Or you can have tail in the first coin and head in the second coin. So how many possible outcomes are here? It's 4. So number of possible outcomes is 4. We need to find probability of getting at the most one head, which means there can be no head at all, which is this one, or there can be one head, this and this. So the favorable outcomes here are head and a tail, both tails, and tail and a head. Now in this particular outcome there are two heads, so this is not favorable to us. Number of favorable outcomes is 3. Hence probability of the event is 3 by 4. So answer is option A. A card is drawn from a well shuffled deck of cards. What is the probability that the card drawn is a red queen card? Now a pack of cards consists of 52 cards which are divided into 4 suits. The 4 suits are spade, hearts, diamonds and clubs, and each suit will have 13 cards. The cards in each suit are ace, king, queen, jack, 10, 9, 8, 7 all the way down to 2. So each suit will have 13 cards and total number of cards is 13 into 4, 52. Now we need to find the probability that the card drawn is a red queen card. First, when a card is drawn from a well shuffled pack of cards, what is the number of possible outcomes? Any one of the 52 cards might be chosen. So, the total number of cards is the possible number of outcomes. What is the number of favorable outcomes? Now, drawing a red queen card is a favorable outcome. How many red queens are there in this pack? 2 red queens are there. One is a queen of hearts and the other is a queen of diamonds. So if any one of these two cards are picked, then it is a favorable outcome. So number of favorable outcomes is 2. Hence the probability will be number of favorable outcomes divided by number of all possible outcomes. So answer will be 1 by 26. Option C. Next, let's do one more sum of the same type. A card is drawn from a well shuffled deck of cards. What is the probability that the card drawn is neither a king nor a queen? Here, this sum can be solved in two ways. Let's see them one by one. First, let's do method 1. The probability that the card drawn is neither a king nor a queen. So let's exclude all the kings and queens in the pack and see how many cards there will be left. There will be 4 kings and 4 queens in any pack. So totally they make 8 cards. Out of the 52, you exclude these 8 cards, you will have 44 cards left. And none of these 44 is either a king or a queen. When one of these 44 cards is selected, then it is a favorable outcome for you. So your probability of getting neither a king nor a queen is, number of favorable outcomes is 44 by total number of outcomes is 52. 11 times in 4 tables and 13 times. So answer is 11 by 13. So I'll repeat one more time. We need to find the probability that the card drawn is neither a king nor a queen. In a pack of cards, the total number of outcomes is 52, which is equal to the total number of cards. And if we exclude the kings and queens in a pack of card, which is 8, 4 kings, 4 queens, you exclude those 8 cards, you will be left with 44 cards. So that is the number of possible outcomes. So, sorry, number of favorable outcomes. So 44 by 52 will give you 11 by 13, which is the probability of getting neither a king nor a queen. Another method is, let's first find the probability of getting a king or a queen. So as we discussed, there are 4 kings and 4 queens in a pack. So totally 8 favorable cards. Any one of these 8, if it is picked, it's a favorable outcome. So your probability of getting a king or a queen is 8 by 52. Probability of not getting a king or a queen will be complementary to this event. So it will be 1 minus 8 by 52, since P of not E is equal to 1 minus P of E. Simplifying this, you get 52 minus 8 by 52, which is 44 by 52. Simplifying, you get 11 by 13. So this is the method 2. Let's move on to the next sum. A box contains cards numbered 6 to 50. A card is drawn at random from the box. Probability that the drawn card has a number which is a perfect square, like 4, 9 is. So there are totally 45 cards and each card is numbered starting from 6 all the way up to 50. So total number of cards will be, number of possible outcomes is total number of cards, which is 45. Now we need to find the probability that the drawn card has a perfect square like 4 and 9. So in this range, what are the perfect squares that we have? 9 is a perfect square. Then you have 4 square, that is 16. 5 square is 25. 6 square is 36. 7 square is 49. And 8 square will be 64, which is above this range. So the favorable outcomes are written here: 9, 16, 25, 36, 49, which are the perfect squares between 6 and 50. So number of favorable outcomes is 1, 2, 3, 4, 5. Hence probability of getting a perfect square card is 5 by 45, which is 1 by 9. Option D is the correct answer. Next, a letter of English alphabets is chosen at random. What is the probability that it is a letter of the word mathematics? So a letter is chosen from the English alphabets. Totally there are 26 alphabets. So number of possible outcomes will be 26. Out of which favorable outcome is choosing a letter from the word mathematics. So the favorable outcomes are choosing either M or A or T, H, E. Mathematics has another M, but we have already chosen it here. A is already considered. T is also considered. So we'll have I, C, and S. These are our favorable outcomes. So number of favorable outcomes is 8. Probability will be 8 by 26. 4 by 13 is the correct answer. Option A. A bag has 5 white marbles, 8 pink marbles, and 4 blue marbles. If we take a marble randomly, then what is the probability of not getting a blue marble? So there are 5 white, 8 pink, and 4 blue marbles. Total number of marbles is 17. So number of possible outcomes is the total number of marbles, which is 17. Now, not getting a blue marble is a favorable event for us. So we should not get a blue marble. Other than blue, there are 13 balls. So these 13 marbles are the favorable outcomes. So number of favorable outcomes will be 13. Hence probability is 13 by 17. Option B is the correct answer. This can be done in other way as well. 5 white marbles, 8 pink marbles, and 4 blue marbles. So total number of marbles is 17. So number of possible outcomes is 17. Let's first find the probability of getting a blue marble. There are 4 blue marbles. So probability of getting a blue marble is 4 by 17. Now probability of not getting a blue marble will be 1 minus 4 by 17. This and this are complementary events. We know that P of not E is equal to 1 minus P of E. So simplifying this, you get 17 minus 4 by 17, which is 13 by 17. So answer is option B, 13 by 17. So there are two methods. You can follow whichever you find it easier. Answer will be the same. That's the end of the video. Thanks for watching and hope you liked it. Please subscribe to our channel and and also press the bell icon to receive notifications as and when we upload new videos. Thank you and have a nice day.